Hi all, welcome to today's video. So today we'll be seeing an interesting design pattern called CQRS. So you might have heard of it or you might have come across this particular design pattern. So this CQRS stands for Command and Query Responsibility Segregation. So this pattern separates the read and update operations for data store. So essentially put, this particular design pattern was developed by Brand Mayer, and the basic principle behind this pattern is to either retrieve information or modify the information, but not do both in the same method or in the same class. In terms of object-oriented programming, what it means is you separate the read against the create, update, or delete operations. You do read separately and you do create, update, or delete records or data separately. That's what it means. So why we are going for CQRS, or why there is a need for CQRS? So the motivation behind CQRS is it has been observed that there is an asymmetry in the read versus the write workloads for a complex application, and also the data model which is expected in the query part is different from the write part. That essentially means there is a clear asymmetry or the clear difference between the workload of write versus read operation. That's the first part. And the second part is whatever data model that we are using for query operation, if you compare it with the data model with the write operation, you don't we don't use most of the some of the columns or some of the properties which we use in the write operation in the user interface side or the query side. So essentially, we separate out the model for two different operations. For write, you use this data model. For read, we use a different data model, so that the data model that we use for individual operations is optimized for that particular operation. So next, we will see the basic block diagram of the CQRS, a simple CQRS model. So first, we will going to see the write part or the write workflow. So it starts from the client, and the client sends request, and while client sends an update request or modify request, it creates a command object. In CQRS, every update operation is done with the help of a command object. And this client sends a command object and it validates whether that particular command object is valid or not. So as to prevent errors down the line. And then we have some business logic which operates on top of this command object, and then after the business logic execution to compute some parameters, it is then passed on to the data persistence layer to write it into the database. So this is how the write workflow happens. And if you are going for a read thing, client does a query to get the relevant information to the read database or the read replica of this database, and it fetches the results and returns back to the client. So if you see the number of blocks which is there in the right side, and if you compare the number of blocks which is in the read side, it is totally different. The client, the write operation is much more heavy in terms of computations. Because there are a lot of computation which is happening in the right side compared to the read side. So once you the here we are using two different databases for the write as well as read. So there is a need to kind of a sync between these two databases. So if you write such particular records to a write database, you need to sync to that particular read replica. So how it can be done? It can be done through eventing. Once you update, once the database write operation happens, it sends an event or emits an event so that the other replicas, the read replicas, can listen to that and update their snapshot, database snapshot. So if you, the good thing, the what is the one of the plus point with this CQRS is that this write and read operations can be scaled independently. So if the particular application demands a heavy read operation, then you can actually increase the number of read replicas so that the query performance will be improved. So like this, you can increase the number of read replicas so that you can get much more faster query. And then coming to the advantages of CQRS, as I told before, it supports this independent scale. So read and write workloads can scale independently. So most of the application that we see is a kind of a read heavy compared to write. So in that case, if you increase the number of read replicas, it can improve the query performance. So the next advantage is the separation of concerns. Means that you are segregating the read and the write model, and you can actually fine tune each model based on the application requirement. So that for that particular operation, that particular model will execute much more faster. So the next big advantage is you can make your query pretty simple. So you can use the custom model. Since we are using two different models for write and read, you can create a custom model which is much suited for your query operations. So that you can avoid the complex join operations, complex table joins. So these are the things that I plan to cover in this video. If you have any other topics in your mind, please do share it in the comment section below. Thank you and see you in the next video.